something about the uh, Fourier synthesis of Fourier series, Fourier transformation, etc., which will be familiar to you because you have studied this kind of concept of Fourier transformation, FT analysis, all those things in your complementary mathematics classes. I'll be briefly discussing that. That is not included in your syllabus, but try to understand what happens in a Fourier synthesis or Fourier transformation. So Fourier transform is named after Jean-Baptiste Joseph Fourier, who's a French mathematician who lived between 1768 and 1830. It is a magical mathematical tool that decomposes any periodic function, which is a function of time, into a sum of sinusoidal basis functions, which is frequency dependent. So you will be having a periodic function, and this periodic function will be converted to a frequency dependent function, frequency dependent sinusoidal function, which is which will be individual function. So upon ft transformation, what you will be getting is you will be having initially a periodic function which is time dependent, which is a function of time, and this would be converted to a sum of sinusoidal function which are frequency dependent. So this particular conversion enables you to understand each of the functions that are combined together to give you the uh, corresponding periodic function. So moving further, you can see here. Um, Here you can see a particular function that is shown as this red line. This is a periodic function. This periodic function is a time dependent function. It's a time dependent function, and it is a sum of 6 sine functions of different amplitudes and harmonically related frequencies, and summing them all together gives you the Fourier series. So this particular function is the periodic function, and these functions are formed by 6 sine functions. Usually sine functions are added together in the case of Fourier transformation of Fourier series to form the Fourier series. So each of this periodic function is a combination of these 6 sine functions. These 6 sine functions combine together, and the summation is the Fourier series that you obtained as the red function. This is the Fourier series, and this one is the function that you obtain by doing the Fourier transformation, and it gives you an idea regarding the amplitude and frequency, how the amplitude varies with frequency. So we are converting the time dependent periodic function to a frequency dependent domain. That is what we are doing during a Fourier transformation. So initially you have functions which will be f1x, f2x, f3x, etc., which are periodic sine functions, and these sine functions will be combined together to give you the Fourier series, which is a periodic function, and this Fourier series will be then undergoing the Fourier transformation to give you the corresponding Fourier transform function of corresponding frequency domain function. So this transformation is done during the Fourier transformation process. So here you can see two different functions, 1 and 2. So just examples. So here the function 2 is the Fourier transform of function 1. This particular function f cap w is the Fourier transform of f of x. You take f of x and you do this kind of a mathematical function on this f of x, you will be getting the Fourier transform. You will be doing the Fourier transform. So 2 is the Fourier transform of 1, and function 1 is the inverse Fourier transform of 2. and this f of x is the inverse Fourier transform of the corresponding function f dash f cap w. So here you can see Fourier transform as well as inverse Fourier transform. So you should have an understanding regarding what is a Fourier series. Fourier series we will be obtaining, the Fourier series will be a periodic function, and it is obtained by a summation of sine functions. Different sine functions you will be combining together or adding up together to give you the Fourier series. From Fourier series you can convert that particular periodic function to Fourier transform by Fourier transformation equations, and by this method you will be converting the time domain functions to a frequency domain function. So this is not a very in-depth explanation. You can go further and understand about Fourier transformation, Fourier series, etc. So Fourier series is an expansion of a periodic function using infinite sum of sines and cosines. Fourier series was initially developed when solving heat equations, but later it was found that the same technique can be used to solve large set of mathematical problems, especially that involve linear differential equations with constant coefficients. So this basic definition is something that should be familiar to you, because Fourier series is a expansion of a periodic function using sum of sines and cosines. So you can express a particular periodic function in terms of sines and cosines as sum of infinite sums of sines and cosines, and that representation is actually the Fourier series. And Fourier transform defines a relationship between a signal in the time domain and its representation is in the frequency domain. So that relation is obtained from the Fourier transformation. Fourier transform decomposes a function into oscillatory functions. Since this is a transformation, the original signal can be obtained from knowing the transformation. Thus, no information is created or lost during the particular process. So Fourier series is an expansion of periodic signal as a linear combination of sines and cosines, while Fourier transform is the process of function used to convert signals from time domain to frequency domain. So you should know what is Fourier series and Fourier transform. What is the difference between these two concepts? Fourier series is a series of sum of cosines and sines. It is a representation used for it is a method used for representing the corresponding periodic function as a sum of sines and cosines. But Fourier transform is a method by which you can convert the time domain functions or signals in time domain to frequency domain, and it will be much more useful for interpretation of a single particular signal.